So good morning, everybody. So my name is Juan Carlos. I'm the co-founder of LookUp, and thank you for having me here with you today to discuss a very passionate topic, which is SSA operational challenge in low Earth orbit. We were told here not to have, we get the constraint of not having a commercial presentation. So I choose not to present on these slides the products and services that we are delivering at LookUp to answer to the operational challenge, but rather to describe why we created LookUp. Okay? So if after this non-commercial presentation you want to know more about the products that we're developing at LookUp, I will be very happy to discuss with you. Okay, so why did we create LookUp? So why my co-founder, so Michel Friling, which was the French space commander, and myself, that I was the head of space safety office at CNES, the French space agency, decided to quit our very passionate and interesting positions to create LookUp. So the reason is simple. It is because the data, the services, and information that we were getting in order to answer to our operational mission was not enough, was not fulfilling the needs that we need to provide high-quality space safety, space security, which is the basis for an efficient space traffic coordination. This is the level of actionability. I will come back to this several times. The level of actionability was far from a target, which is needed to provide efficient space safety and space security services. So what do we have to develop? On which field do we have to work in order to have this efficient space traffic coordination? So we have to work in what I call the holy trinity of space safety and security, which is based on a very basic principle that applies to many domains, which is in order to act, you need to understand precisely. And in order to understand precisely, you need to observe. And not observing every now and then. You have to observe efficiently. Without this observation, you are not able to build knowledge. And without that knowledge, you are just acting on a random manner. So this is the kind of principle that guided us when we created LookUp in order to build this system that we would like to have when we were at our previous position at the Ministry of Defense and the agency, which is built on the three pillars, this trinity: detection and tracking, knowledge building, and action. A few words about observation. Again, you don't have. We need to observe from a persistent manner. Observing every now and then, letting Mother Nature allowing us to observe objects is not the good way. So we have to develop capabilities to observe on a persistent manner, to have a global monitoring, to have high revisit rates. This can only be reached through global networks. Because at the end, what we want is, if we need to observe a given object, we observe it. It's not, let's see if I can observe it. You have to observe it. So this, again, can be only reached through global networks, can be reached through technologies that allow you to have this persistent capability, that allow us to detect objects on a high revisit rates, every orbit or higher, that allow us to have what we call large geometrical diversity, which is key to compute high accurate orbits. This is lower covariances, small covariances, which are fundamental for many applications which is needed for space traffic coordination, and we need to go down in size, go to sub-catalog population, because the highest threat to space safety is coming from that population. So only when you're able to observe, then you are able to build knowledge. You have to model, you have to perform multi-phenomenology data fusion, you have to work with high fidelity modeling to build and to understand orbital behaviors in order to anticipate, characterize, and deconflict risky situations. In 2 words, you need to build actionable insights. As I say, the time for poo-pourri data and insights is over. So having some data, having some computation, getting some CDMs, getting some values is not enough. It's not anymore enough. You have to observe accurately, observe frequently, build this knowledge through data fusion, through high fidelity modeling, and build these actionable insights. It's only then when you're able to observe persistently, accurately, to build that knowledge, that then you're able to act. And the action is not happening only on collision avoidance. Many people is talking about collision avoidance, which is a key element. Action is built all over the life cycle. It starts from mission planning, and even it starts from regulation. We need this action going on an holistic manner. And each of these use cases that I have put here has their very specific technical challenges that we can spend hours discussing. For example, so I talked with mission planning, ConOps that allows for efficient space traffic coordination. LeOps, we have huge uncertainties. We have rate share missions that makes today that many operators are waiting hours or days before knowing which satellites belong to them. And even we are losing satellites before they can even become operational. Traffic coordination has been discussed. We have a huge asymmetry between concept of operations, between information, between the one sharing the maneuver plans, the one not sharing anything. There are even operators that are not able to compute accurate orbit for their satellites. We don't know maneuver plans, what are they going to do, and more basically, in some cases, or in many cases, we don't even know who to contact when we have a contingency. So decommissioning, I will not describe all of them because it's not going to take some time, and I have 2 minutes left. Decommissioning, we have huge uncertainties on the Delta V budget when we are arriving at the end of mission. These uncertainties are leading to huge uncertainties on the maneuvers, which is leading to huge covariances at the end of life, which lead us to low actionability. So we are not able to guarantee safety on this final phase of the mission. So this is the last slide. So which is the system that we would like, that Michel, as his French space commander, and myself, when I was at the head of space safety at CNES, would have loved to have? It's a system that is able to observe on an efficient manner, accurately, persistently, build knowledge, and take action. And this is not every one and then. It's on a high frequency loop. We need to be able to observe persistently, to track objects that are involved on events of interest, to be able to holistically decide which is the way of action to guarantee safety and security, and then ultimately act on a timely manner. Thank you.